Gases. This chapter will describe the behavior of gases. Some of you may think that gases are not as relevant to chemistry as maybe solids and liquids and solutions. However, it is actually very important. So you have gases right now in your body, such as oxygen gas, nitrogen gas, etc. The understanding the gases here and their behavior will help you be able to understand how basic things that we take for granted, like breathing, takes place, or actually how your car engine works. So quickly, how do we describe gases? I always like to start by using one of the most important theories in science, and that's called the kinetic molecular theory of gases. And the kinetic molecular theory describes something called an ideal gas. Ideal. By ideal, we don't mean perfect. It's just a gas with certain behavior. There are 5 postulates or assumptions. I'm going to summarize them for you very, very quick. Number 1 is that gases consist of large numbers of molecules that are in continuous random motion. Okay, just remember that there is a lot and random. The volume of all molecules of gas is negligible compared to the volume of the container. They have no volume. The molecules. So by no volume, I don't mean no volume at all. There's no such thing in nature, right? There's volume, but again, the gas molecules, they have no volume. Repulsive or attractive forces, they are neutral. Collisions among gas molecules are perfectly elastic. Energy can be transferred between molecules during collisions. Again, no change in energy. In terms of the whole system. And the average kinetic energy of molecules is proportional to the absolute temperature, which means that the higher the temperature, the higher the kinetic energy. The lower the temperature, the lower the kinetic energy. That's a nice way of explaining that. So let's show you this on a simulation that we will use later. So if you look here, we have a lot and they're in random motion. Second is when we say no volume, this may not do justice to it, but this is a very, very large look at it. It's a very, very large gas vessel container. So if you take all of these gas molecules, put them together, their volume will be very, very small at the ideal gas behavior. The next one is talking about that there's no attractive repulsive forces. You don't see a positive attracting a negative repelling a negative. And fourth is look at them, they are transferring energy between them, but that energy is conserved. It's within this gas sample, meaning that if you can track one, if it hits another one, it's going to make it move faster. And then that one is going to bump into another one. It's going to make it move faster, and on and on and on and on. And then lastly is if I increase, let's say if I increase the temperature, you're going to see that they're going to move faster. So keep watching, which means their kinetic energy is going to go up. These are the postulates of the kinetic molecular theory. Make sure you remember them, make sure you understand them, because you will get questions about applying them. Okay, so don't just memorize them. This is not the class to just memorize things. Be able to apply them if you're giving a scenario. So if I give you a scenario like this on a quiz, whatever you say, yes, the higher the temperature, the more the kinetic energy. That's what a theory does. It helps us explain, and theories are the most important part. For gas parameters, there are 4 of them you have to keep in mind. We always talk about its volume, and it's the volume of the container. That's V. Temperature is in Kelvin. It cannot be calculated or used in calculation in Celsius. It has to be in Kelvin. And if you recall that equation, or if you don't remember it, it's K equals the degree in Celsius plus 273. So you always add 273. So you cannot use Celsius or Fahrenheit. Moles, that's what N is. So if you have grams, you have to convert to moles. And finally, pressure is the result of these. If we go back to show you this is because this is good, this is what pressure is. These are colliding with each other, and they're colliding with the walls of the container. And that's what pressure is. It builds up these forces, again, impacting or striking these walls. They're creating a force, and then that would result in what we call pressure. Now, pressure, which of course here it is in a physical sense, pressure is, let me erase this, is used in the following unit. You have 1 ATM, 760 millimeters of Hg, 760 torr, etc. So this is the conversion for them. Now, gas laws, what I need you to do is, I'm not going to go over them in the videos here. All you have to know is that make sure you remember what the statement says and make sure you know how to apply them. We're not going to do any calculations, but this should be a repeat. You should have seen this before. So remember each named gas law and the relationship, and of course, be able to apply it to a certain, let's say, scenario.